And I ran out of space in the phone, so I've lost a little bit what I said there. I was talking without being aware that the recording stopped. But anyhow, so I'm going to quickly sum this up by saying, but to first continue where I ended is, like I said, we could either use wave mechanics or matrix mechanics to explain these things. And I said we use wave mechanics because it's easier to visualize. Matrix mechanics, nobody knows how to visualize that really. But what we can, so we don't know what it is, but what we can say, there is something there. And the motivation why we're using the wave mechanics or the matrix mechanics is because they make predictions that correlates to these events. And here I want to stress a second point. I said this is events, and this is a justification for calling it events, because if it's external reasons, we could talk about something that flows in the field there, that there is something that exists, that there is an independent object that's like manifests itself during the observations. But it can also be due to internal reasons that these bumps exist. And that internal reason is that the individual spots is just changing their energy level for whatever reasons, and we don't know why. And if there is an internal reason for this thing, we can't say that they really are connected with each other. So and that means that it's just something that happens. It just happens to go up and down. And maybe there is some global rule that says that, well, if the energy level goes up here, then the neighboring has to go up too. Or if the energy level goes down here, then the neighbor has to go down. Maybe, I don't know. But or it could be completely independent of each other. It's just what the field is doing. The point here is then, it's just things that happens. It's what could be called an action in the field. The field has actions. If this is an external reason for something that is actually moving around here in the field, then we could talk about causal relation. Because remember, we're coming back to the two slits experiment. We have a source and a target, which is the screen. The screen, target. We have an event here, an observation here, and an observation on the screen. This is two events. If it's a bump that moves around there, there is an object, then there is a cause for this observation here, the B observation, and this is the A observation. The cause of the B observation is the A observation. But if there is purely internal reasons with a field that it is doing stuff, then we can't talk about a causal relation, cause and effect relation. So this is the effect and this is the cause. And with the bump moving, we are thinking about like this is the cause and this is the effect. But with the field going up and down, this is no longer a cause. This is just something that happened there. And this is just something that happened there. It's an event. And and in fact, physics today is not thinking about cause, effect. They are not thinking cause effect. They're thinking action. An action is not a cause and effect, but there is something that is called least action. And if you investigate least action, what you will find is that least action is corresponding to cause and effect. Least action can be thought of as cause and effect, but it isn't. It's least action is just like things that happens and actions. The third point I want to make is that, so we started out with two observations which we wanted to explain. We explained it with something else which we haven't observed, and there was things going on in this, what I called a field. There are things going on in this field that requires further explanation. Why is the value changing in each spot? And that was explained by yet another thing, and this is a surface, and on that surface we could map to an energy level, and that energy level, that energy that was in that particular spot, was then giving rise to the changes of the values in the field. So we have yet another thing, but this is not observed. And I also said that this space here is not extending out of that point, it's in that point. It's a mathematical description, it's an abstract thing, and it doesn't exist. What exists is a point with the values that goes up and down, and we just use this to explain, we just use this mathematical representation here to explain why the values went up and down. And in the same fashion, we use this field to explain why there is something here at 12 o'clock and then something there at 1 minute past. So we can then ask, but how do we explain the occurrence of this? And then we get something else there to explain. And we get this endless chain regression of things to explain. And we end up in the same situation as the Greek did, that how small pieces can matter be divided into, but instead of asking matter, we're now asking how small pieces can how should I call it, the things we let's say it causes, and we just end up in a situation where we have to explain the things which we haven't observed. I want to stress it, which we haven't observed. The details of them exist, and so on and so on. And at some point we have to draw a line to say that we can do. No, we don't have to, but we can do as the Greeks did. At some point we draw a line and said, like, yeah, here is stop, it just happens. We just accept that this is as it is. And then, and we could motivate this by the following, that, okay, we haven't observed this, but we could say that, yeah, there is actually something there. Because otherwise we just ends up in like yeah, is there something or not? No, there is. That's not really the thing that exists, but this exists. Because if I said if this is an internal reason, then this doesn't exist. So does this exist, or is there an internal reason for this as well? That's the chain we have to break, and we could break it here. Why? Because we haven't observed this. We don't know what it is. This one was used to explain this. But then we run into problem here, like, okay, so how does this work? Oh, well, then we made up this explanation. But you see where this goes. We have to stop it, because we haven't seen this. So this is just speculations. The only thing we could say, we know if it breaks the change, we could say there is something that exists. There is something that exists in reality. If we don't break the change of explanations, then we're going to end up to say there is nothing. Reality is nothing. But we know there is something, and we know there is something because we observe these events. And I've told you what quantum mechanics said. There is no persistence of existence, but there is a correlation between events. And this is coming back to what I said, that there may or may not be internal reasons, there may or may not be external reasons for these things, which is behind the scene, as to say, in the field. And what we can do is to take a more neutral approach to this, because if we claim this exists, there is no internal reason for it, then we could talk about cause and effect here. But we can't be sure because we haven't seen it, and we don't actually know what the case is. Is this wave because of something that flows in the field, or is it because just some kind of behavior locally in each spot in the field? We don't know. So it may be internal reasons. And what we can do instead is say, like, okay, so there is just something that happened here. Something happened here in the field. Something happened here in the field. There was an action in the field. And then we could look at the least actions in the field by, this is A observation, B observation, and a C observation. And we could say that the least action of the field is to have something here. That something is here. And maybe it's something here as well. And here, and here, and here, and here. The least action to going from A to B is a straight line. That's the least action. And that straight line motion we could associate with a particle. But that's an interpretation. And then we could say, if we interpret it as a particle, then we could say the effect here in B is caused by A. We could say that if we do that interpretation. But we don't have to do that interpretation. We could just say there is action here, and this is the least action. And the least action doesn't mean that A caused B. It doesn't mean it. It's just the least action, because the least action could be like a path like this. And why wouldn't that happen? I've explained for you in a field, if we, in that two slits experiment there, we have the entire room over here. And I told like this, and I told you the field is present in the entire room. And there may be a tiny little possibility that we detect something up here. So does that mean we had like a path over here? Instead of detecting here, we could detect a path like this. It's a possibility to do that. It's a possibility that this happened. And why does it happen? Well, we don't know. It can happen, but it's not the least action.